All right, to try it, for example, 1 part B, we're putting in 6x minus 2x squared. Does anybody know before we hit graph, you probably already did, what kind of shape this will make? Good, parabola. Will it be happy or sad? Sad, meaning that it's upside down, meaning it opens down and achieves a max or min? It reaches a max. Okay, let's see it on Zoom 6. All right, is the maximum on the screen? So we don't have to go searching for it. Sometimes you have to make your window taller, lower, righter, or lefter, all right, to find the max. For that, let's say the max was, above 10. You'd have to go to Window and pump up your Y max more than 10 to find what you're looking for, all right? If the max was off the screen to the right, you'd make your X max bigger. Left, X min, down, Y min, all right? Just a little refresher on using the calculator. Graph. All right, we need domain and range. Here we go. Here we go. Domain. The x's you're allowed to put in to a parabola. Is it anything goes? Can I put in any number, multiply it by 6, and take away double that number squared? Because that's the function, right? Can I take any number in the world? I'm going to hit trace so it comes up. Could I put in 5? Multiply it by 6 and take away 2 times 5 squared. Is 5 allowed to go into this function? Yes? Yes. Could I put in 17,000? Could you take 6 times 17,000 and take away? Yes, okay. So any number can go in. And you can see that because this parabola continues to go left and it continues to go right, and it covers every x along the way. So one way to say the domain is all what kind of numbers? Yes, all real numbers, none of those fake numbers, all right? More on that later in the year. They're not fake, they're called imaginary, all right? So all real numbers, or you say it this way, the domain is everything from who to what? Negative infinity to positive infinity. And the range? Uh-oh. Jumped the gun there on the range. What's the highest point for y that it reaches? Oh. Is the domain always negative infinity to positive infinity? No, not always. Lots of times it is, because usually, lots of times you can put any number you want into the function, but not every number will come out of the function. All right? Here's a function where you can't just put anything you want in. All right? Can I square root 49? Can I square root 1? Can I square root 0? Say yes. Yes. Can I, on the real number system, square root -3? No. In that case, I can't put in negative numbers, so this domain would go from 0 to infinity. That's how you say non-negative numbers, from 0 to infinity. Is this the first time you're seeing interval notation in any math class, or did you see it in Algebra 1? You think you saw it in Algebra 1? Okay, good. If you don't remember it, you'll get the hang of it. It's not bad. Maybe you wrote it this way. The x's have to be greater than or equal to 0. Right? Maybe you saw it like that. Right? This and this are different ways to say the same thing. All right? Now let's get back to this one. How can we figure out the highest point that this parabola reaches? What do you think? Use the trace. Okay. Let's trace. I'm on that. I'm going to erase this because it was a side note. And let's try to trace it to the right. All right, am I there yet? Am I there now? Do we have a, you think we have a good estimate? For the highest, we're looking at y. What's the highest y? 4.5-ish. Yeah. So we have to say a domain is 4.5-ish and less, right? A 4.5-ish, I know what you mean by 4.5-ish, but 4.5-ish isn't a real number, right? It's an ish number. So we need to pinpoint that maximum. Let's get a... Okay, we could plug in an x value. What do you think that x value might be? Let's try it. 1.5, enter. Ooh, now we're not 4.5-ish. We're at what? 4.5 no-ish, right? Just 4.5. Guess what? Let's say what? You can go to, do you know this trace button we've been hitting? What's above it? What's up? Calculate. Oh, you'll hear this a lot this year. What's better than trace? Second trace. What's better than trace? Ooh, if you look at the second trace screen, what's option 4? It'll find the maximum for you. Aha. So when you go to second trace, calculate, you can hit maximum. Now, a lesson in finding the maximum. You see this little blinky right now as it sits. Move it to the left, anywhere over here. Put it over there somewhere. Because it wants you to establish a left bound. It needs like a little window to look inside to find the maximum. So you're telling it go from here to there and look for a maximum in that zone. So move it to the left a little bit and hit enter. What's the next question it's given you? Right bound. Move it to the right of the bump. Move it to the right, till you get up over the hill. Anywhere. Hit enter. You've established this region or this zone where the calculator is going to look for the max. That's what you're setting up. When you hit enter, it'll tell you that it's at 1.5 rounded, comma 4.5. So your 4.5-ish was right. It's 4.5. That's the max. That's the highest y that it reaches. So in the old days, you might say the y's are only less than or equal to, because it hits what? 4.5. In interval notation, what do you think? I'm going to go this way as you say it, okay? That'll be that set builder notation when you do that x less than or equal to. Yeah. This is how we say it in interval notation. Notice how I wrote it the other way. Listen. The y values are allowed to be as far down as what? This parabola goes down. Whoa. It goes down this way, and where does it end? Never, right? So it goes down as far as what? Negative infinity. It keeps growing until it reaches a cap of what? 4.5, and that's where it stops. That's what that notation will look like. Okay?